Okay. All right. Let's start. You guys gonna stand, or if you want to sit? So yeah, welcome to the React.js events in Barcelona. It's at our office. We actually just moved in recently here, so might not look fully finished. We're still working on it, but it's good that we kick it off with a nice event here. Maybe just quick words about what we do. So we're Logify, and I don't know how many of you guys know what Shopify is. Okay, most of you. So great. So what we do is basically exactly the same thing, but we're totally focusing only on lodging operators, specifically vacation rentals, holiday rentals, the so-called alternative accommodation space. So what we're doing is very similar to Shopify. We're building websites for them on a self-service basis. So we're software that allows them to build a website where they can immediately accept bookings, manage their reservations, synchronize their data to different channels, like Airbnb, for example. We're connected to Airbnb. We provide them with properties that they're bookable. And we're also trying to build a platform where external designers and developers, they can build on top of our platform. So we allow them to customize our websites and also build apps on top of that. Our technology stack is React.js, obviously. That's why we're here. But connected to a .NET API. And we just migrated to Google Cloud. And yeah, we actually also look for full stack developers who know React.js and .NET. So if you're interested or if you're looking for a job, then just reach out to me or Marco, who's my CTO and co-founder, or Francesca, who sits in the corner at the back. And yeah, we have 2 presentations coming up, followed by a Q&A, both of them. So the first one would be presented by Alex, the second one by Daniel. Where is he? Oh, there you go. And then we have some booze afterwards. So we have some beer and Coca-Cola for the ones that have to drive potentially. So yeah, enjoy, and we'll see you around later in the kitchen. So I hand it over to Alex.
Thank you. Literally handing it over.
Yeah, exactly.
Works. Cool. Nice. Hello. Thank you very much for coming. Can you hear me well at the very end? Awesome. So I want to talk today about Next. So this is not pure React. We're not talking about React, but this is very closely related to the React ecosystem. So I work at CircleCI, and we use a lot of ClojureScript, right? ClojureScript is a compiler for Clojure that targets JavaScript. Clojure, in turn, you might know, is a very nice functional dynamic dialect of Lisp. So ClojureScript looks pretty much like this. There's a lot of parentheses, opening, closing, a lot of arrows, a lot of weird stuff. Don't be scared. It's nice. It's great actually. And ClojureScript is actually allowing us to do a lot of really cool stuff. So for example, we can get really good performance out of our application in comparison to if we were writing it in bare React.js, right? We can do code sharing between the backend and the frontend because our backend is written in Clojure. And so we have a whole namespace of utility functions that we can use both on frontend and on backend. And we also can do interactive development. It's not really a game changer, but it's kind of cool, right? So CircleCI backend was written in Clojure since the very beginning, and so it made sense to just use frontend, use the same language on the front end if it were possible. And so at the same time wanted to use React, and using JavaScript directly from ClojureScript is not that much of fun. I mean, you can totally do it, but it's not the best idea generally. And so then this thing came up, this is a React wrapper for ClojureScript, right? And everybody was like, yeah, amazing, this is happening. So this turned out to be one of our front end turned out to be one of the first production ClojureScript and OM applications, and eventually one of the largest production and OM applications in the world. So right now we have more than 20,000 lines of pure ClojureScript. This is not counting, obviously, tests, library is, that we are using underneath, not counting CSS even, all this stuff. So that's a lot of ClojureScript. And this all goodness is open source. You can take a look at our front end in our GitHub profile. So as I said, OM is a React wrapper for ClojureScript, and this is pretty much how you use it. So supposing that we want to write the magic hello world thing in React, first we do some kind of markup that we'll use that we will populate with React later. So this is nothing complicated, just a div right there that we will use later. Then we write this. So first of all, we require a bunch of libraries that we'll be using. So you can see there is a Google library in there from Google Clojure utilities. Then there is OM DOM manipulation utilities and OM next that I will be talking about later. Then we use this nice macro to define the component. We say that it will override a method of an object class. We tell it that it's going to be a render method. It's going to perform this action. It's going to go to the DOM function, the DOM namespace, and call the div function. Going to create a div. And then we wrap all this into a thing called onFactory, which creates an actual React component. And then we call JavaScript right there, call React render, give it the component, give it the DOM element, and hooray, we have the thing. So this is how the result looks in the DOM. So this is exactly what you would get if you were using pure React. So far, so good, right? So, but why we're using OM is not just because we want to use ClojureScript on the front end. It's because OM is not just a React wrapper for ClojureScript. It's more stuff. So the thing that we find most valuable is built-in global state management. So you might have heard of Redux, and you probably are familiar with a lot of use cases for that. So probably you don't need global app state if you write only pure React components. But your components are probably not pure if you're doing anything useful in your application, right? Manipulating data on the backend and all that stuff. So sometimes your components got to change the state of other components which are completely unrelated to your current component, and that's where global state management comes into play. So, for example, an e-commerce website with a shopping cart, right? You have a product component right there. It has a button in there, maybe its own component, whatever. And here you have the shopping cart that has a products list, products and cart. And what happens is when you add a product to cart, you cannot directly update this component from there, right? This is not possible. But what you can do is have a thing called app state, and then you update that, and then you re-render the product cart, and bam, it has all the new data. So what OM does with this is it makes accessing and manipulating the global state easy. So this is the example that we were talking about previously. Let's change it a bit, and I'll go line by line. We added the app state here. So item is in the Clojure world is immutable state of data. So we give this a description of the app state. We changed the name of the component. Of course, it's no longer hello world thing. It's a counter now. Here we start to get the properties of the component from the state, so that we can use it. We can change the component in real time. Then here we get the key called count from the app state. So the syntax there is a bit weird, but don't be scared. It's you can do it in simpler ways as well. Here, as you can see, you can already use the count variable, and so we can just get the value that was there in the app state. Here we just make a button, DOM button element, and attach some on-click events for it. So for example, this function will be triggered on click on the button. What it's going to do, it's going to go to the app state. It's going to update the value count with a function called increment. So it's going to increment the count from 0 to 1, from 1 to 2, and so on. This is a thing that will help us put the state into the component. And this is the actual thing that's going to attach the component to the DOM. So what happens is, after all this, we'll have something like this. It's going to be a real counter written in OM plus React. So this is the very silly usage of global app state. You could totally do this with like component state, right? This is completely useless. But there are actual like real like proper use cases for global app state. So for example, if you're, as I said, if you want to update a state of one component from the other, or maybe you don't want to update data synchronously, right? You want to store some stuff in an application state and then send it over asynchronously in the background, and in the meanwhile update the UI with some intermediate result. Or maybe you want to load less data by reusing the same data in different components, right? You load it once, you use it everywhere. Sounds like Java, right? So this is OM. In addition, as we said, in addition to wrapping React, it implements the global app state out of the box and makes it easier to use. So this is OM, but I wanted to talk a bit about OM next. This is a new thing that the creators of OM came up with. This is an incremental improvement upon OM, and it introduces some really interesting new concepts. So to start with, there is new component syntax. This is the example we were looking at previously. This is already the new syntax. The old syntax was just a bit different. There is like a small difference right there. It's a small difference, but it adds, in a large code base, it adds a lot of application. When you need to specify render and then render again, and then if you change the signature of one of those functions, you have to change the other one. And we had countless failed CI builds, if somebody changes one thing and not the other. So the new syntax is nice and clean, and it has the additional benefit is that the result of processing the component created with this def UI thing is the actual React component, which was not the case previously. So it's nice. It's good for debugging. It's useful. It's nice, but it's still minor. Let's talk about something a bit more major, like data fetching. So this is an actual production thing that we have on our website right now. If you go to project settings, there is a way to add an SSH key for your project so that you can SSH into servers for deployment, whatever. There's this add SSH key button in there. It's implemented underneath using all this stuff and more. Let's focus on one thing here that I want to talk about. So here, this is the we use the button component that we wrote. It's also open source. You can take a look at it if you're interested in it. What it does is, on click, it raises an asynchronous control event that in turn gets handled by a controller that performs that is called saved SSH key, which is the name of the action. And it calls sends the Ajax query to the server with a certain name. And then we have another controller, which is an API controller, which comes into action on success of that call, and then goes to the app state and puts the result of the Ajax call into the app state. And then we have another controller that acts after the previous controller and sends another, and then sends another Ajax request to update the new version of the project settings. So it turns out that button is triggering a bunch of Ajax requests, right? So we trigger an event from the component that issues an Ajax request. Then we have another controller, another controller, another controller, right? That's amazing. And so with the new data fetching patterns in OmNext, this becomes slightly irrelevant. So there's a thing being introduced right now called OmNext reconciler. So this is not the React reconciler that you might have thought about, but this is a thing that's going to sit between the server, the application state, and the React tree, right there in the middle. What's gonna do is app state right now is becoming a tree, and the reconciler is going to manage that. The tree structure itself is inspired by GraphQL and is designed to be able to maintain correlation with GraphQL in the future. And the components, on their part, instead of just receiving props, they specify the data that they need to be able to function. And so this reconciler thing, we tell it how to fetch the parts that we care about for a certain component. We also tell it how to update certain parts of data received from the component on the server. And for example, with the SSH button, right now what we are going to do, we're going to access the reconciler, and then the reconciler is going to access the app state and the server. What's going to happen here is that the state updates that we were doing in one of the controllers, they become completely irrelevant. And there is a huge 1,000-line file, which is our API controllers, and this is just going to be deleted. This is going to be amazing. Data fetching is transparent for the application. So for example, we have, let's say we have an SSH key component, and it has a few properties. And the first time we fetch that key, we're going to fetch the ID, let's say, from the server. And then the next time it's going to be served from the local cache completely automatically. The fact that component data is defined as queries and is similar to GraphQL allows us to understand what data do components use. You know, sometimes we've seen cases where we pass the entire app state to a component and we have no idea what that uses. Here we are kind of trying to solve that problem if we use this, of course. We can also do HTTP caching out of the box because it's really easy to understand what kind of data do we need to fetch from the server every time, what kind of data we can store in the state and use it. We can also do optimistic updates really easily. So for example, if we have the same case, SSH key button, we make a request to the reconciler because the button was clicked. That shows the key right there in the project settings, and then sends the request to the server updating the key. Then the response from the server comes back, and we add the ID into the app state. And we have the key in some intermediate state before that. This also means that we're going to simplify unit testing in the front end, because right now we have a lot of WebDriver tests that just go in and click a bunch of buttons and expect some results to happen on the back end. With this, we will be able to take some kind of state and then parse the React tree resulting from that state. This is going to be amazing. Yeah, instead of like mocking all the APIs, we will just step out specific data points. Also means that we're going to do a more efficient initial load, because it just allows us to load less data, right? So that's how the reconciler is gonna change this all data fetching. There's also another thing that I'm pretty excited about. In OmNext, they introduced server-side rendering. So basically, in the same way that we were writing components previously, you can write a component on the backend and then render it to string, send it over, and React will just attach the listeners, and it's going to be it. It's going to be super, super fast. It's amazing. So with all this goodness, we're going to go and use new syntax for the components, because it's backwards compatible, which is nice. We already use the new app state tree with all the query goodness. Then we're going to start to write actual queries that perform well, only fetch the data that we care about. Maybe we will implement GraphQL support, but that's still in the works, not even in the works, just in the talks. And yeah, this is the part I love the most. We'll just erase the whole 1,000-line files. Yeah, it's going to be great. So one warning though, OmNext is not production ready. So Om is production ready and we are using it. OmNext is officially not in the release stage yet, which doesn't mean that we're not going to use it in production, but you might want to wait until the release happens. So to recap all this thing, as I said, Om is really nice. OmNext introduces a lot of new features. You might want to give it a try. You can check out the documentation, play around with the examples. It's really easy to get started with the amount of examples given in the documentation, the quality of the examples in there. And the good thing about Om is that the community is evolving constantly. And so Om as the framework is going to get better with time. We are going to contribute some things. Other people using it are investing a lot of resources in it, and so it's going to get better every day. Thank you very much. Time for questions now. Cool. What else can I tell you? Sure.
Do you think you can use the reconciler without using the OM, like using reagent or reframe?
Yes. So the question was if you can potentially use the reconciler without using all other OM stuff, right? Rendering and all this stuff. So I don't think it makes too much sense to use that. You might be better off using Redux, for example, that implements its own reconciling mechanisms. Although if you try that out, I would be excited to see the result. Thank you. Sure.
I was wondering how well this interoperates with other JavaScript libraries. Is that something you just kind of include other JavaScript? Or?
Yeah, so the question was if this is something that can be used easily with other JavaScript libraries. So it's fairly easy, I would say. So it's not super seamless, but it's good enough. So in one of the examples, I might be able to find it now. There is a way to just use JavaScript right there. Oh, here. This is a good one. Yeah, I'll fix it now. Give me a second. So here, why is it showing? Can I hear what? Do I choose? No, shit. No.
The top one. Open
Top one?
Yeah.
Okay. No, it just shows the browser.
Yeah.
It shows the browser.
It's just
No. Okay, never mind. So basically, yes, you can use JavaScript libraries right there. The mechanism of requiring JavaScript libraries is currently actively being worked at. It's not that you can mix JavaScript code and ClojureScript code in the single file yet. But in theory, you could. Perfect. Thank you very much. So here, there is an example right there at the bottom of using JavaScript call. So this actually goes out to JavaScript and calls a function only available there.
Are there like definition files required to use a specific? Right, is there anything that checks that render method exists, or do you just need to get it right?
No, you just need to get it right. Yes, you can make some logic around that yourself, so that you can only call like specific.
Like definition files or
No.
anything like that.
Nope. Any other questions? Sure.
Can I debug the original source code in the browser?
Yes. So there are a few developer tools. One of them is Dirac, I think DIRAC, which allows you to trace error messages to ClojureScript files and not to compiled JavaScript files. So that's generally only possible in development environment. So you would not have that in production generally, just because all the code is very minified and no source maps are provided, whatever. But in development environment, yeah, we currently do that a lot. So I would say that it's not not in 100% of cases you will have that perfect traceability, but in most cases where the problem is actually with your code, you will have that visibility. Any other questions? Sure.
You mentioned some stuff about kind of interactive, like when you were developing it, it sounded almost like you were going to say do like hot reloading or something like that.
Yes. So the question was if you can do hot reloading and other cool stuff during development. Yes. One of the most popular development tools for ClojureScript is called Figwheel. It actually actively reloads all the code in the browser. So you update some ClojureScript, you update your component, bam, you have it right there, updated in your browser within maybe 1 second or even less. We also tweaked it to work with our less compilation mechanism. So when we update less, the same thing happens. Everything recompiles and it's instantly displayed in the browser. Any other questions? All right. Thank you very much.
This is one. We are ready for the second talk. Yeah, welcome, Daniel.
Okay, hello, good afternoon. I'm Daniel de la Cruz, and I'm going to talk about implementing feature toggles in React-based application. First of all, I'm going to talk about me a little. This picture is before having kids, so this is the result of it. Yeah, I've been more of 10 years developing web applications, some of them with loads of traffic. I also like to code in JS and C#. I'm currently working as a tech lead in typeform.com. And if you want to come after this talk just to talk to me, I like to play video games, so you have a nice topic to start talking with me. Also, you can find my Twitter profile and my GitHub profile if you want to stalk me. So feature toggle. What is a feature toggle? How many of you knows what is a feature toggle? Raise your hand, don't be shy. Okay, a lot of you knows what it is. So if you have read probably the definition of Martin Fowler, basically a feature toggle is a technique, a powerful technique that he says that allows a teams to change some behavior in production without releasing any code. So this part to not release any code is something tricky, and is something that we forget when implementing feature toggle, and this is the key of implementing successfully a feature toggle. So here we have an example. Let's imagine a calculation algorithm that is implemented as it is, and it's not perfect for you, and you want to change it. You can do two things. Do a big refactor and change everything and release it, and then cross your fingers and go on holidays and see what happens. Or you can do it in a safer way, implementing, for example, a feature toggle. This is a very, very naive implementation of a feature toggle. Basically, you have some Boolean that says you if you are on the new algorithm or not, and then you make a statement to decide if you want to use the enhanced version or the current version. But if you want to change this behavior in production, you have to do a release. You have to release some code and commenting this and setting this flag to true, and you don't want to do this because you don't want to do releasing when something goes wrong in production. So that's the trick of implementing a feature toggle. Typically, you have like a function that asks somewhere else a safer place if the feature toggle is active or not. It may be an API, a server, a file in a CDN, wherever that is outside your code. This function typically asks to this repository is the feature toggle is toggle or not, if it's active or not, and then toggles over the new function or the old function. Also, when we talk about feature toggles, we also talk about the toggle routers. Toggle router is basically a configuration that tells you which feature toggles are active or not. You can implement it, and then in your code you can ask to it if a feature is active, and also you can provide some configuration, because you may want to have a feature toggle, for example, that change some text in your code, some styles, anything that you can imagine, and anything that it's tied to this toggle. So why would you like to use feature toggle? Here is some inspiration from the product's perspective. If you are lean thinkers, if you are following a lean startup approach in your company, you may want to put the learning first when releasing something. So you don't want to do a big design, a big feature without learning from your users first. So if you want to learn, if you want to get some data about how your users are using your features, a feature toggle is a nice technique to have. A feature toggle may help you, for example, to do A/B testing. For example, well, I'm missing a slide. Oh, okay, it's here. A/B testing, for example, to show a couple of variations of a same feature and see what is the version that the users are using the most. For example, we used feature toggles in Fotocasa, which is the company that I was working before, to decide a lot of things about the classified cards that we were using to the real estate advertisement. For example, sorry, in the version on the left is the old one, and the version on the right is the right one. We introduced it, for example, a slider. We changed the background. We changed the typography. All of this was toggled with a feature toggle, and this is something useful because you learn just by toggling new features. For example, at Typhon, which is the company that we are using now, we are doing A/B testing or feature toggles for deciding which is the most appropriate page for the candidates to pay when the customers are subscribing to our Pro product. This is the page that they see, and we may want to improve and optimize the call to actions in this page. So we may want to use a feature toggle here. This is the new version that we are seeing, and this is the current version, and we may measure which one performs the best. Another use case that we are using for a feature toggle is the version 2 of the platform of Typhon. This is a switch that you may find in the admin panel, and if the toggle is active, the new version, which is totally new, is showing to the user, and you can test it before releasing it. It is really useful for doing canary releasing. So when you are trying to implement a feature toggle in React-based applications, you have some challenges. The first one is how to implement a feature toggle in a single-page application. Typically, when you have a feature toggle, you rely on a backend, and this backend decides which is the right view to show to the user, and it is pretty easy to make this decision in a backend world because you have more tools to it. But if your users are living in a single-page application, a lot of stuff happens on the client, and you have to make this decision on the client. Another challenge that you may have to face is how to keep my code clean. When we saw the previous example, we have some branching in the code, and if you start doing this in your production code base, you may end with an ugly code base full of feature toggles that nobody after that remembers to remove, and this is kind of tricky. To keep your code base clean. And the third one is, how do I make feature toggles work in universal apps? For example, in apps that are being rendered on the server, and when you send to the client and it re-renders, it has to show the same feature toggle that was decided on the server. So these are the three challenges that we had when I was working on Fotocasa, and we came up with a library that is open source and you can use, which is React Feature Toggle. This is a universal library that just helps you to implement feature toggles. It's a really simple library, and which is more important about how to implement it is the patterns that you follow that using this library, because this library just doesn't do everything for you. It just helps you to make your code clean, to make a feature toggle in a universal app, and also to make it work in a single-page application. So when we designed this, what we wanted to do is just avoid having the feature toggle code across all the component hierarchy of my application. So we only have to implement in the entry point of the application to provide the toggles, and also in the component of the hierarchy that is triggering the feature toggle. This is really powerful because if you only have to change, for example, one button or one copy or one small component like a card that I showed before, you don't have to contaminate the full tree of components of your application. So these are the features which I already talked about. How do you use it? First of all, the first step is just create your components and its variation. For example, if you are creating a card, you may want to test it with 3 different backgrounds to see which color is more engaging for your users. If you start doing this, you just create these 3 components as if you were not implementing any feature toggle. These components are production ready. So it means that if one of them wins in your test, you just have to use it and delete the other components from your code base. This is a suggestion about how to organize your component folder tree. Typically, I like to have an index folder and then an index in the root of the folder and then a folder for every variation. This allows me just to have no branching in my code. When I just decide with my feature toggle that the variation B, for example, is the winner, I just remove the other folders and my code is clean. So in the index file in the root of my folder, I import all the variation and I wrap all of them in a toggle component. Toggle component is just a simple class that provides the React feature toggle library and just receives the feature toggles from the entry point of the application and decides which of these variation is going to be shown to the user. I'm going to explain the technical details about this toggle component later, but just stick with me that in the index, in the root of the toggle component, you are doing this. The fourth step is just use your component normally. If you are using a card, for example, all the components in the middle of the hierarchy doesn't have to be aware that you are using a feature toggle. For example, if you have a card list, this card list doesn't realize about anything that happens inside the card. Fifth step is to define your experiments. We were defining a JSON file and serving from a static repository to show which were the experiments running in our application. For example, which is important here is to have the variations array, and in this variations array, I inform which are the variations currently active in my application. Another thing that was useful is this force property that we were using to decide which was the winner. When we were activating a feature toggle, we were measuring it with a monitoring tool, and we were seeing the interactions in every of the variation. When we decided which one was the winner, we just uploaded this JSON file to this static repository by forcing the winner version, and we didn't have to release any code until the next release. We didn't have to release any code just for a feature toggle winning. The sixth step is to create a strategy to decide which toggle are you going to use. This is also important because if a user ends up in your application, you may always want to show that user the same variation. If he returns after a while, you don't want to show him another variation. So this is where strategy is important. You may want to implement this strategy as you want. It is free to you. It is not related with the library. But which is important is the output of this strategy. The output should be the actual toggles object that uses your application. Every request needs a toggles object to decide which of the variations I need to show to the user. So with this strategy, you typically go through the variations array in the experiments object and decide which one are you going to show. And the strategy is up to you. You may want to use a user unique identifier or a random approach or whatever you want to use, but you need to output something like this. Then in the end, as a last step, in the entry point of your application, you just wrap your application with a toggle app, which is the other module provided by the library, and you provide your app with the toggles object that you decide using the strategies. Yeah, this is about the strategies. I already talk about this. What about universal apps? Which is tricky about universal apps is, as I said, that you have to make the same decision in the server and in the client. When you run your code in the server to render to string your application, the decision needs to be the same that it is going to be in the server. So for performing this, the library provides a universal module that allows you to inject the toggles object into your markup, which is the same approach that other isomorphic or universal libraries do. This is, for example, based on React Transmit, which is exactly the same approach. The result of this module is just a markup in your page with the toggles object already decided with the strategy, and then on client code, instead of providing the result of the strategy, you just point to the window.card toggles object. So how does it work? This is the most important thing. You may think, how does it work? It's just magic. Sorry, I just wanted to put this GIF in the presentation. Yeah, the two utilities that the library offers you, toggle component and toggle app, are just higher order components. This is interesting because with a higher order component, you just can wrap your components without modifying the actual code. If you see the, I'm going to show it later, but if you see the card code, it doesn't receive anything about toggles object or anything related with toggles. It just receives props, the props that it needs to be rendered. This component is production ready. And then this is why I want to wrap it with a higher order component, with something that is not agnostic to what is going to be rendered. And it is useful for any type of component. So the toggle app just assigns the toggle object to the context, and this is how I am able to pass all the toggles object across the component tree. And with the toggle component, I just read this object from the context, just check if some of the components passed by parameter matches with the name of the toggle, and then make the decision to show it or not. Also, if the toggle has properties, for example, or it assigns to the properties of the toggle component. And that's pretty much it. I'm going to show some code. I don't know if it's worth, I can show it if you ask me, but also this is the GitHub repo. And this is a demo page of this. This is the GitHub repo, sorry. Which is open source. You can open issues here or just give me feedback about it. And it has also a demo page, which is this. This one, these are the cards that I'm using in a hypothetical application, and the strategy that I used here to decide which component to toggle was a random approach. And when I hit refresh, it is going to show me. Well, I wasn't lucky. Come on, that's it. So it is going to show me just another of the three approaches. It has three variations, one with different background and another one with yet another background, but overwriting the props. Let me see if I'm lucky. Yeah, random. Okay, come on. Yes, this is toggling the titles and the description. That's pretty much it. You may never want to do a random strategy in production. This is just for showing how it works. What I usually like to do is to use something deterministic of the user, like the ID or a unique user ID or something that you may have to identify that user and always send the same variation to it. So I think that's it. Questions? I don't know. Just go ahead.
At the microphone, do you use this library in conjunction with third-party A/B test tools like Visual Web Optimizer?
Yes, we are not using it in Typeform yet, but it is being used. Sorry, I didn't repeat the question. The question was if we are using this library in Typeform or not, right? In conjunction with other A/B testing tools, yes. No, we are not using it in Typeform yet because we are doing just internal releases, but it is being used in Photocasa, which is my previous company, and we did it all the tooling by ourselves. We didn't use with another tools. That's it. but it is independent on which tool do you use to do the feature toggle. I mean, this only allows you to, given some decision that is made somewhere, provide your application with a toggle subject and make your code killing. That's it.
I was just wondering about how you have like the metrics to measure the success.
Yeah, the metrics. This library doesn't provide you any tool for doing the metrics, but in Photocasa they use Elasticsearch and Kibana, but you can use anything you want. It is New Relic, Dynatrace, whatever you want. What else?
Can you please show a slide with the strategy example?
Yeah. Let me find it because I don't remember where is it. No, this is not it. I just want to show it again. Thing is. No. This one, okay.
So this is result of strategy function, right?
Yeah, this is the result of the strategy function.
It returns just object.
Yes, not yet.
Is the name of component.
The name of the variation,
Yeah, but
and the props are the props that this component is going to receive.
just plain JavaScript object. The
Yes.
key is a string, but if we do some bundling or something like this string should match display name of component or.
Yes, that's interesting. Yes, I didn't explain that, but this yes, it has to match the display name of the component. This is the trick. You are right. You are so smart. I forgot about it. Yes. Okay. So yeah, thank you.
So thank you everyone again for attending today, and we have a lot of time for networking and beers and water, anything that drives you. So let's go.